Good evening, everybody. Welcome. We've got a few more people joining the chat, so excuse us as we admit them. And also, I want to personally apologize to everybody. I'm normally in charge of our waiting music, and I often advocate for Taylor Swift. I did not realize that some of these songs from her latest album were expletive laden, so I feel obliged to apologize. That was not Aaron's selection.
Thanks for covering me there, Blake. Appreciate it.
But welcome, everybody. Tonight, we're going to be covering how to build what we call pre-statistical skills through graphing. My quick background, I was a math teacher, grew up loving math, so it always kills me when people say that they hate math and they hate statistics. We think that using real data sets and using our tool, DataClassroom, we can make it so that people don't hate statistics and that they're no longer scary when we think of them as an applied skill and show students how to use them in a real-world setting. So we're going to go through that tonight. I know it's good to see some familiar faces. So many of you have heard our intros before, but for those of you who haven't, Aaron will be leading our conversation. He has been a high school biology teacher. He has been a professional biologist. He's been a TEDx main stage speaker. And now he acts as the CEO and founder of DataClassroom. So he's going to take us through some of his best strategies that he learned over the course of his time teaching, as well as working as a professional scientist.
Thanks for the introduction, Blake. I'm just admitting some other people in the waiting room. And Blake, I think you should be able to let people in now too, as a co-host. Yeah, we're actually in bringing this webinar back. This is a reprisal of one that we did about a year and a half ago. That was our best attended webinar ever. So we thought we'd run it again. And I think the reason it's a popular topic because a lot of people do find statistics intimidating. And I know certainly when I was in my own classroom, I would frequently get myself into situations with student collected data where I didn't really know what the right answer was. And that can be a scary place to be when you're, up in a room in front of 30 or 35 students. We like to have the answers. I think that's in some ways, though, that is just kind of a characteristic of statistics, is that there is not often just one right answer or one way to do something or one way to present data. But there is a bit of inherent uncertainty in statistics. And I think that embracing that can actually make it more comfortable to teach a topic that often doesn't just have one right answer. So what we're going to do today, just an outline of our presentation, so you know where we're going to take you. We're going to kind of continue this welcome and introductory discussion. We'd love to hear in the chat if some of you do find statistics intimidating or a little bit scary. We would love to have you, drop that in the chat of why you think that might be so. So if you do find statistics intimidating or scary in any way, go ahead and share that in the chat if you would be willing, and we'll kind of work that into our discussion. Then we're going to go over a couple of principles for teaching statistics as an applied skill, as I think that is one of the ways that can make it a little bit less intimidating when you really think of it as something that you do and practice rather than something that you learn and master in just purely an academic setting without actually doing it. So like other applied skills, like say take carpentry, for example, you can continue to improve with it through doing it. But you will never master it in a true sense. You can continue to become stronger and stronger in applying statistics. And then we're going to work through an example. We're going to work through the digital data nugget on the DataClassroom platform, the digital data nugget called Dangerously Bold, which is about fish personalities. It's a study of bluegills in an experimental pond. And we're going to go through two different questions with that data set and work them through from question to graph to stats and seeing how everything flows from that question. I guess if we could have just a little bit of conversation, my chat is not fully functioning, Blake, so I'm relying on you to
Sure.
bring up what has come in the chat. If anything if anyone has shared anything in there, if not, I can just kind of start out and talk about, some of the things that I've found intimidating about statistics in my journey along the way and in working with statistics over the last really 20 years now.
We do have some feedback from the chat. We are not wrong in assuming that stats are intimidating. One comment was, I don't know how to support our teachers. Another comment was that there's a gap in between what science research expects and what is taught in AP stats. It's another example of a teacher kind of, being intimidated maybe by the range of stats they're expected to wield. Sonia has shared very candidly that she took and failed stats in college because it was scary and intimidating and never made sense. Sonia, that's because your teachers didn't make it an applied skill.
It's interesting that talking about that gap between AP stats and then what you're doing in a research setting, like a research course with teachers or a science fair program, what's expected at the state level competitions. It's really interesting because I think, and I don't really want to speak ill of College Board. I actually like the people that I've dealt with there. I've talked to the coordinator of AP Stats a number of times, as well as the coordinator of AP Bio. I think we have a good relationship with them. But one of the things that they've talked about in conversations with them that I've had about stats is they are attempting to move from that sort of academic teaching of stats to a more applied version of stats. So I think if you talk to the folks at College Board and AP Stats, they also agree philosophically in teaching stats as an applied discipline. But that is absolutely true. And I don't want to be too opaque here, but I think what I mean when we're teaching stats from an applied perspective is focusing on questions and problems, and then using statistics as a tool to get the answers to those problems, to solve those problems. And that's what I mean by applied. The opposite of that, and sort of the more traditional way of teaching stats, is really to give you all the background information about the assumptions and the distributions and things that sort of underlie the math behind statistical tests, particularly hypothesis tests, and how that works. But I think the problem with doing it that way is that a lot of it is very abstract when you're not actually working with a real data set and a real problem, and you're not visualizing data that you're using to work on a real life problem. And all of a sudden, when you are working on a real life problem, all of that sort of purely academic stuff suddenly just makes more sense. And so that's I think, one of the advantages. And again, I'll use that analogy to a very applied skill, something like carpentry. Learning carpentry from a book, you could do it, but just a lot of the things that you will learn will not make sense until you actually get in there and do it. And I think the same is true when working with data. One thing I want to add too that I think is intimidating about learning stats and working with stats, and maybe some of you have had the same experience, is stat seems like something that real scientists do. I think because stats are wielded so frequently in statistics, it's hard to find any kind of modern scientific publication that isn't just jam-packed with statistical jargon and abbreviations, and that can be kind of intimidating when you're coming into it. In my perspective, I was in a high school classroom for 7 years, and then spent about a decade on the research side of things as an evolutionary ecologist. And one of the things that I found kind of surprising is that a lot of practicing scientists are not necessarily experts in stats. And they too, when reading a scientific paper, they may not quite understand when someone says we did such and such an analysis, they may not understand exactly what that means, but there's sort of key metrics in when you're reporting statistical results, and degrees of freedom, and some kind of a value of a test statistic, and some kind of a p-value. And it almost doesn't matter if you don't fully understand the exact statistical test they ran, but kind of what those things generally are. What degrees of freedom are, what the test statistic is and what its role is, and how to interpret a p-value. And so that's, I think, one thing is you gain fluency in stats. You don't necessarily become an expert in all statistical tests, but you understand how to read them and sort of what's
and Aaron, if I could chime in on that point, I think it relates nicely to what Tim had put in the chat, was that it's often difficult to teach high school and middle school students in applied settings because examples in textbooks and curricula don't match up perfectly to the research they're doing. And I think that we're conditioned as educators, and students are conditioned as math students especially, that there should be a right answer, like in algebra and geometry, x equals something, or some postulate proves something. But in statistics, it's messy. Sometimes we have to take 2 steps back after looking at a graph, and our analysis requires context. And that's not the case in other math subjects where we think there's a right and a wrong. And the reality is stats are messy, and even professional scientists can be imprecise or have to correct for lack of precision when using and reporting their stats.
Yeah, absolutely. It is messy. There are no black and whites, including things like p-values, right? There's you cannot just because you have a certain p-value, above or below some arbitrary cutoff threshold, does not necessarily mean, this is so and this is the right answer, but it's always weighing the evidence and the experimental design and forming a conclusion and then saying how confident you are in that conclusion. So I think with that, maybe this is a time to jump in. I want to point out that I'm going to show you kind of 4 points. This is not necessarily a step-by-step process of saying do number 1, do number 2, and so forth. But these are just kind of 4 things that I think are helpful to keep in mind when you're working with statistics, when you're teaching students statistics. And one, I don't want to belabor this point too much, but one is you teach stats as an applied skill. And I think this is really true at every level. I will say that, whether you are middle school, whether you're high school, whether you are working with university students, I think this is even true in working with graduate students, but teaching stats as an applied skill makes the most sense to me. Number 2 is to focus on the question. And so I think to say I want to teach about a t-test without focusing on the types of questions and actual questions that you can use that tool to answer doesn't make sense. So again, we want to focus on the question. And even if you are diving deep into the math of how a particular statistical test works, I think that keeping that question at the forefront and saying, we're doing this test because we want to quantify the strength of the evidence we have that we're using in the service of answering this question. So you never want to lose sight of the question. One of my favorite things to ask undergrad researchers when they would come to me with a result and they'd say, I got a p-value of 0.03, or I got the p-value of 0.23, and say, great, what question does that help you answer? And so you want students to think and slow down and just think about what is that question. And then number 3 is get to the real data as quickly as you can. And so I do understand that there are some situations where you want to give a little bit of a background of what you're going to do statistically or what you're going to learn about. But I think the longer that goes on before you get an actual data set in front of students, you drift further away from that principle that statistics should be an applied skill. So get to the real data as quickly as you can. I think, quite honestly, if you want to introduce some statistical concept, sometimes it makes sense to have the data set be the very first thing you give them and have them actually use the data set to frame the question, talk about what kind of data you would want to have and what you would want to know, and then say, well, we have this particular statistical method. Now we're going to learn about this. This is the a little feedback there. And then a fourth tip that I find really helpful when you move on to statistics is emphasize conceptual understanding through graphs. And so, like, I think when what we'll look at today, we'll look at both the t-test and we'll look at the chi-square goodness of fit, but talking about what those tests are doing and pointing to the graph that illustrates that test. I think for a good number of statistical tests, you can illustrate those with a graph. And I sort of think most statistical tests, until you get to things like multiple linear regression, that becomes a little bit tricky to illustrate with a single graph. But sort of prior to that, so whether it's ANOVA or two-way ANOVA or t-test or chi-square or all of those tests, there are graphs that can illustrate those tests. So you can say, this is the picture version of my test. And when I run my stats, I'm doing the exact same thing that my eyes are doing when I'm sort of sizing up this data and saying, what do I think the conclusion is here? And the statistical test is not revealing some brand new truth about the universe, but it is simply putting a number to the confidence that you can have in that result. So your statistical test in most cases should not be a surprise. And if it is, you should really go back and look at your data and see if that makes sense. But it should rather give you sort of some kind of metric of strength and confidence in the evidence that you have. So I think a lot of this, again, we said focus on a question. And so I think it pays to think about the types of research questions that students might be using. And I have, within DataClassroom, we have broken these up into proportions, change over time, variability, comparing groups, and relationships. I think these are 5 categories that I'm not going to necessarily say will cover every single thing that you would want to apply statistics to, but this will cover 95%. And I'm not necessarily statistically confident in that estimate, but they're going to cover most situations. And within DataClassroom, the Graph Wizard tool is sort of the manifestation of this. And this is meant to help with graph choice. And it's really also tied into the help that we have built in for choosing statistical tests in there as well. Blake's alarm is going off. I have to say, if you've noticed and you're wondering, why are Blake and Aaron in matching uniforms? We're down in Dallas, Texas right now at the CAST conference, which is the Science Teachers Association in Texas. So we came straight from the trade show floor. And so we are in our DataClassroom t-shirts and hoodies. So with those 5 types of
those articles are also all online at Science News.
There we go.
.org. And those articles are.
We've got someone unmuted, but I think they'll figure that out. So, and to show you how the logic of question and graph choice can lead you to appropriate statistical tests, I started working on this figure, and I'll say this is kind of a work in progress. We're actually hoping to turn this in to a classroom poster that DataClassroom is gonna put out, and this is sort of our rough draft of that figure. But it just kind of goes through, and I want to break this down and just sort of walk through this step by step. So when you have research questions that are about proportions, and so these are questions about, like, do you have equal probability of survival or death? And it's like, you're looking at a category, or you're looking at, did we take equal number of samples from males and females? Those are kind of proportion questions. And when you're looking at a single variable, this is this arrow furthest to the left with these 3 graph types here. And those are pretty much always going to lead to chi-square goodness of fit statistical tests. And when you have proportion questions that are looking at 2 variables at once, that's the second arrow from the left. And that's going to lead to chi-square test of independence. And so you can see there's kind of multiple graphing options for each of those, but they're going to, they're going to lead to that test. And then change over time. And I'm going to say something about change over time. When I'm mentoring science fair students or working with science fair mentors, change over time questions are extremely common. This is an area that kids gravitate toward when they're thinking of research questions. I will also say statistically, they're some of the most challenging often, and from an experimental design perspective, they're challenging. These, if you have just kind of a simple case where you want to look at a trend over time in a simple XY with only one group, sometimes a linear regression can be the right choice for that. But oftentimes, when you're wanting to maybe compare the shape of the curves in change over time between multiple treatment groups, this leads to something called a repeated measures ANOVA, which is something that DataClassroom actually won't do for you. But I just kind of wanted to make you aware of this, and also just that caveat that if you dive into a complex experiment with change over time, sometimes that pushes you into very, very complex stats. And so, for that reason, I a lot of times with research students or science fair, I do try to steer students away from that sometimes, unless it is absolutely, they have a great question and that just so happens to be the stats they need to use. Questions of variability and this is the middle category here. This is shape of the data types of questions. Oftentimes these aren't leading to a statistical test, but sometimes they are if you are asking the question of, are these data normally distributed? And there's tests of normality. DataClassroom runs two different tests of normality. One of them is the D'Agostino-Pearson test. And quite honestly, the other test is escaping me at this point. But if you go in to run that test of normality, you'll see those kinds of tests there. Then the fourth one over is this comparing groups category. And this is things where if you're comparing two groups, this is t-test. If you're comparing more than two groups, this is ANOVA. And if you're comparing or if you want to know the effects simultaneously of two different categorical variables on some numeric variable that you're measuring, that's a two-way ANOVA kind of question. And then relationships. And in relationships questions, if you're looking at just two variables, how does X affect Y? That's going to be a linear regression. And if you have two separate groups and you want to know, how X affects Y across the different groups, and if it affects them in the same way across both groups, this is where you can do an ANCOVA. And I'll say the ANCOVA is available in the DataClassroom U package, which if you are a teacher account, you can switch back and forth between DataClassroom and DataClassroom U at any time. And that's in your profile is where you'll go to do that. You just change your grade level from middle school, high school to college, and you'll get the DataClassroom U package running. Okay, so we're going to go through some examples for the rest of this. I'm going to try to follow my own advice and keep stats teaching as an applied discipline. So we're going to look at two questions. We're going to look at one, does fish personality, bold versus shy, affect the probability of survival in fish? And two, does fish personality affect the summer growth of fish? And this is in this dangerously bold data nugget. Blake, do you have a link to that you can drop in the chat for people?
Just did.
Excellent. Okay, so we're going to look at each of these, and we're going to talk about which data do we need, and we can even do that before we go over to the example. Just kind of thinking what data would we need to answer these questions. Which graph will illustrate our question, and we can think about that for each of them. And I can also show you how to use the graph wizard help within DataClassroom. And then which stats will help evaluate the confidence in our conclusion. And again, we're going to kind of do the intellectual work to frame the question and visualize it first. And then the stats test is just going to flow from that. And I'll say, you know, it is nice to, you know, have a strong background in stats and know which test is going to be a fit for which situation, but that is not necessarily something you have to memorize right away to guide students through statistics effectively. This is the kind of thing, you know, I'll give you the slides for this presentation. So, you know, you can have that figure and see which tests flow from which graphs, but this is also information that, you know, there's a number of very useful flow charts out. And we will include some of those in the follow-up workshop material. And there is nothing wrong with saying, okay, let's identify your question. Let's frame what kind of question is it? And, you know, what is your graph going to look like? And then from that point saying, okay, well, now I'm going to go to a reference and look at what statistical test should we be using. And with time, that will start to, you know, become second nature to you. You start to realize, oh, this is pretty clear-cut t-test data, or this is ANOVA data, or this is chi-square data. But you don't necessarily have to know that to, you know, right away to effectively guide students in applying statistics. So let's take this first question. Does fish personality, and we've indicated this is going to be bold versus shy, affect the probability of survival in fish? So just to give you a little background, this was done in experimental ponds at Michigan State University. And they ran these fish through a number of behavioral assays, number of behavioral tests, and scored them in their personalities on this boldness, shyness axis. And then after they had done that, they binned them into categories and saying, this is a bold fish. It has a high sort of score on this axis. This is a shy fish. It has a low score on this axis. So they've binned those into categories. And thinking about the data that we need, so we need to know what category they were in. Were they bold or shy? And then the probability of survival in fish, we need to know what the outcome was. And so this is also going to be a categorical. We need to know whether they lived or died over the time period of the study. And so this number one is category versus category here. And so we'll look at that in a second. We'll talk about what graphs would illustrate that and what stats we would use. So for the second question, does personality affect the summer growth of fish? In talking about the data that we need to know the size of the fish in the beginning of the study, and we need to know the size of the fish in the end. And then we need that same piece of data for each fish that we had in number one. Which category are they in? Were they bold or shy? And an interesting thing about this data set and how the study was conducted, they did not actually publish the data on the size of the fish at the start of the study. But what they did was they assembled fish in their two groups, bold and shy, and measured them, tested that there was no statistical difference between the two groups in size. And then, so they're only going to do a comparison of the two groups at the end and see if there is a statistical difference, knowing that there wasn't in the beginning. And again, this is one of those sort of messy things about working with real data. Is that the ideal way to do this? No, probably not. In an ideal world, you would want to do probably some kind of paired t-test design where you were, you know, measuring a fish at the start, measuring a fish at the end, you know, and checking that way. You know, but it didn't quite work out that way. Another difficulty on this is that we can't take the end summer weight for the fish that didn't survive, because if they're not there to be measured at the end, we can only either measure the survivors, which is what they did in this case, or have their beginning weights, but we can't measure them at the end if they are no longer with us. So with that, I'm going to jump over to DataClassroom. If you don't have a DataClassroom account, you can go to dataclassroom.com and create one, or you can also go to u.dataclassroom.com if you want to create a DataClassroom U account. But again, if you're a teacher, you can switch back and forth between those two accounts. So I'm gonna stop my screen share right now, and I'm gonna get ready to share my DataClassroom screen. and share my browser with you. Sorry, that was just sharing with you the exact same screen. Let me move my Zoom windows, and here we go. So I'm logged into DataClassroom. I'm going to go over to the resource library, and the data set here. I had a filter in already, but if you search the word bold, it will come up, and it actually, because I was just modifying it, it should be the first data set that comes up in the resource library, even with no filter. So I'm going to go ahead and open this data set, and I'll say, under the assignment tab, there is the whole assignment and questions that will take you through this. And I'll just pop over there for a second and show that. This is still loading here. This is the data nugget, and just to kind of show you how we've set up these digital data nuggets. If you've never been to the Data Nuggets website, they're datanuggets.org, and I highly recommend it. They have really, really great pencil and paper activities for working with data. They really tell the story behind the data. Kind of, who were the scientists involved? What were they, what was their thought process? But we've modified this slightly so that it works really well to do it as a digital activity in DataClassroom. And then we've also at the end added some digital extension questions. So doing some things that you wouldn't want to do with pencil and paper that you would probably only want to undertake in a digital environment. Some of those things are, applying some statistics. And this data set, while not, absolutely enormous, I think it is, here, I'll go back to the table and look at how big it is. So it's 100 data points, or sorry, it's 200 data points. If I show all the data, it's 200 data points. So this is, beyond the size what I think you would want to do any kind of graphing or statistics by hand here. And so I'm going to use Graph Wizard to help us get to the graph, and we will take that. Maybe I'm going to start with that question number 2 of is there a difference in growth between the bold and shy individuals? So we'll tackle question number 2, because I know that it's going to lead to a t-test, and I think that the t-test is a better starting place for statistics learners than the chi-square. I think it's a little bit easier to explain what's going on with it. And so I'm going to open up this under this visualization in the flow chart up here. I'm going to click graph because I want to get to this graph wizard. So this purple button that says open the graph wizard. And you'll only be able to, if you're following along, you're either going to be on a free trial or a license to use this particular feature, but I can show you how to do it without this feature as well. And we're going to think about this question. So remember, we wanted this data of, are they bold or shy, and did they live or die? And so we have to classify this as to what kind of question this is. And if we read through these, the only one that's going to fit here is proportions, because we want to know how data are distributed among different categories. We really want to know, do we see basically the same proportions of bold and shy individuals in the categories of survived and died, right? We want to see, so these are proportions. And this is a 2x2 test, because we have 2 variables that each have 2 values. So the one variable is personality, and it's either bold or shy. The other variable is we'll call it fate, and it's either lived or died. And so if I go down this proportions path, we're looking at 2 variables at once. So it's asking, again, if you go down the path on the left, if you're just looking at 1, if you're looking at 2, you go on the right. And again, even if you're not using Graph Wizard or a Graph Wizard type tool for this is the same logic that you're using if you know statistics well and you're sort of going through, okay, what test is going to fit for this situation? But this can be recreated, with a paper flow chart as well. So we're looking at 2 variables. And we'll say our first variable is behavior. Sorry, it's called behavior in this data set, not personality. And second variable is, I've got to move my Zoom window. Second variable is fate. And so when we go to this, we've got 3 viable options to illustrate this. And again, this is a situation where there's not one right answer always when working with data. These are 3 equally valid ways to represent this data. I'm gonna use the stacked bar graph with X and Z variables. I kind of like this one, but just to kind of show you, if I go here, move down there, say, show me the steps, and I'm just gonna have the DataClassroom set this up for me. This is making this stacked bar chart, and you can see here we have equal sample sizes. We have 100 in each group, and so we're kind of looking at this. And again, you know, our question is, does personality affect whether they lived or died? One thing I want to point out: if we didn't have equal numbers for this kind of question, it can, oh, sorry, we don't have equal numbers. I had already ticked this box. So, so here, wait, let me go into, oh yeah, it is, sorry. It is, we're using this stacked, but what I wanted to show is that you can choose to stack this as a proportion. And so this will work if you have unequal sample sizes. This will help scale it visually. And you can see here when I uncheck it, this is like what the default stacked bar graph looks like, where you can see the raw number is the y-axis, but I can also do this as a proportion where it will convert that y-axis to proportion. It will often change the heights of the bars so that they are both 100% of however many you had across those 2 categories. And so, you know, from here, this is probably all we need to get a pretty good answer to our question. So, you know, what do you think? Does it look like behavior significantly impacted the fate of these fish? What do you think when looking at with your eyes? Maybe we could get you to weigh in the chat. Do you think behavior, did it have an effect on fate or did it not? And Blake, I can't see my chat, so you're going to have to tell me what the audience thinks.
Our first vote is a vote of no effect from Sunita Howard. No effect.
What else?
2 votes for no. 3 votes no.
Mm-hmm. And I want to point out that you do not need statistics to answer a question with data, right? You are perfectly capable of looking at this and saying, do these data convince me of an effect, right? And it seems like, so it was only a couple of votes, but so far, no, you know, you are not convinced that behavior affected fate. And I would say, if you run the statistics and it tells you something different than what your eyes are telling you, I think you should really go, like, then critically look at that and say, wait, why is it saying that? Did I misassess this in some way? You know, what's going on? Because
not working.
Statistics is a lot of times going to, you know, be a way to put a number to what you're seeing when you're looking at a visual of the data. If I go over here to the control panel at the right and I run this graph-driven hypothesis test, this is going to launch a chi-square test of independence. And a chi-square test of independence is doing exactly what we just did with our eyes. It is mathematically testing if it looks like the class of behavior, whether bold or shy, influenced fate. It's saying, is this variable influencing the other variable, or are they independent of one another? And so you can see the graph-driven test is recommending the chi-square test of independence. When I could calculate, we get this box. And if some of you haven't been in DataClassroom in a while, this might be new to you, but this pop-up kind of shows, you know, when should you use it? Well, this test is used if you have 2 categorical variables and want to know if the value of one appears to be dependent on the other, right? That's what we're looking. We want to know if fate depends on behavior. And it works by comparing observed and expected frequencies of each combination of the categorical variables. You can also do our, you know, animated chi-square test, which it works for goodness of fit, to dive into that a little bit little bit more deeply. But I can, when I run this, you know, I can see I have, you know, 1 degree of freedom because I have these 2 categories. My chi-square test statistic is 1.16, and my p-value is 0.28, which is typically interpreted by science as meaning little to no indication there's a relationship here. So, you know, this would be interpreted, you know, more or less the same way that you as an audience interpreted this with your eyes as well. So again, I think when you frame this as, okay, we can choose a graph, and we can choose a graph by thinking about what kind of question.
It's by choice. I don't have to do it.
And then we produce a graph, and we look at that graph critically, and we draw a conclusion. And then we say, okay, now we're going to apply some statistics, but really we're just going to try to look at, you know, what is the degree of confidence that we have in that conclusion. And, you know, basically that p-value of 0.28 is saying, well, we would expect a difference in lived and died of this magnitude, you know, among these bold and shy groups, you know, roughly 28% of the time by random chance alone. And then that, you know, that's saying like, yeah, this difference between these 2 groups, this is something that we might just expect to see at random. And in fact, you know, we're going to conclude that is probably the most likely explanation for what we're seeing.
And Aaron, I just want to chime in and kind of emphasize one point you're saying, which is that when we conduct these experiments, when your students conduct research, the point is not to get a certain number for your p-value, but to feel confident answering the question of whether or not there's a difference.
Absolutely. Absolutely. You definitely should not get hung up on p-values, because quite honestly, you know, whatever you put as your cutoff, say it's 0.05 commonly, there really is no difference in how you should really interpret a result of, you know, 0.055 or 0.045, right? Like those are essentially, like, you have the exact same amount of general confidence or qualitative confidence in that result. And it's not like a magic switch is flipped, you know, when P is either less than 0.05 or greater than 0.05. To do that is really sort of abusing, you know, how that math actually works. Okay, so let's take the second question here. So I'm gonna clear this off entirely. So we had the second question of, you know, does personality affect growth in the fish? And remember, we're limited to just looking at the fish that survived here, and those are the ones that have the length and weight measurements. And again, now you can probably already see there, you know, we don't have a variable that's called growth, but we have one that's called length, and we have one that's called weight. So this means we can actually explore this question, you know, with 2 different response variables. We'll go with weight first. So I can plot the weight, and I was still on graphs, the histogram frequency bar plot. And so we can see, you know, what this looks like. I'm actually going to switch over to the dot plot for this, but you could do it with either. So I can see each data point is a different fish in here, and all of the, you know, the fate of the, or the behavior of the fish is all lumped together. So these are all the bold and shy individuals together. To split those apart, I could add behavior on here. And this is about the simplest graph that shows all the data that we could, this is about the simplest graph we could make that happens to show all of the data. And so we can start looking at this. And I will say, I think this one is perhaps a little bit harder to just, you know, come to a quick snap judgment. I feel like the last graph, you were pretty confident right away. They are like, yeah, it doesn't look like behavior has an effect on fate. But in this one, you know, does behavior have an effect on weight? This, you know, you might kind of have to look at the points a little bit more closely and start thinking about it. This is a great point to bring in what I call pre-statistical thinking, or pre-statistical addition. I think everything that we've been doing looking at the graphs is pre-statistical thinking, but a pre-statistical visual that is really can be helpful is you might want to know what the average is of each group, or you might want to know what the median is of each group. So if I click this descriptive stats, I can see the bar, the height of each bar is the median. And the error bars above and below are showing right now one standard error of the mean. I'm gonna actually go to 95% confidence interval because I like that a little bit better for visually interpreting data, especially if, before going to a statistical test here. And this is gonna, as we go through this is a good example for a lot of reasons. But now, looking at these, the height of the bars is definitely different, and we have a pretty good size sample. Those 95% confidence intervals are overlapping just slightly. Okay, they are overlapping just slightly. And you may have heard the sort of snap, like if confidence over intervals are overlapping, then it's not significant. And that's not always true with 95% confidence intervals. What is true, if 95% confidence intervals are not overlapping, then it is definitely a p-value of less than 0.05. But when they are overlapping, there is some gray area there where you can still have a significant result. Another way you might choose to look at these is you might want to look at the medians and how the interquartile is distributed. So the box shows us the middle 50% of the data, and look and see, are those offset from one another? And one thing that I think is helpful to do when teaching, and I'm going to go in the appearance menu and move those box plots off to the left there. But one thing I like to do when you're evaluating a data set like this, just visually, I like to show students, I'm going to actually go back in the appearance menu because I also am not a huge fan of the bars for means. I think representing them as a dot and seeing the confidence intervals around them that way is sometimes visually a little bit easier to look at. But showing these data three ways where, we're seeing the raw data points that go into that, and we're seeing abstractions off to the left, where we're looking at, and I'll compress those a little bit, but we're looking at, where is the mean for each group, and where is the median, where is the interquartile. And so we're looking at this. I'm curious, some of you may have already run the stats test while I've been talking about this, but in the chat, what do you think? Do you think this is a significant difference in body weight between the bold and the shy individuals here?
Aaron, I hope I haven't biased the responses. I went ahead, I haven't done this test recently, and just from looking at the 95% confidence intervals and the number of data points, I think we're going to be pretty close to significant. That was just my vote. I think we are going to be just over the line.
Yeah, and this is, typically when you're working with data sets of some decent size, like do you have more than 50 points in each group? And we do here. Even very small differences in mean can be statistically significant. And in fact, if we do run this t-test, I believe this is statistically significant at 0.05. So, interpreted as some confidence that the groups are different. We would say this result is significant. But the thing I would, I think you should invite students to talk about in this is look at the magnitude of the difference, or what we call the effect size here. And given the amount of variation you see in body size, and knowing that, the mean difference between the groups is, so looking at the mean body weight for the bold individuals was 5.48 grams. And I'm just looking at this table off to the right here. And the mean for the shy individuals was 4.79 grams. That's a pretty subtle difference given the amount of variation. So you definitely, you would not be able to just pick up a fish from this pond and say, oh, this is for sure a bold individual based on its size, or this is a shy individual. And so that's important to talk about with students, that just because this result is significant statistically, I'm pretty confident that behavior does have an effect on body weight. It might not necessarily be very biologically meaningful, and it certainly is not diagnostic of behavior type in this data set. So that's something talk about. One thing I also want to show, we were talking about how, we had a question, which is a comparing groups question that led us to make the kind of graph we did, this dot plot, but we could have also looked at this as histograms. This is the exact same data. This is a perfectly valid graph. There's not one right answer to do this. But because this is a comparing groups question and it is two groups and we're comparing them based on a numeric variable, it's still going to lead us to that t-test. And again, whether you're using the data classroom, graph wizard and graph-driven hypothesis test in tandem, or whether you're consulting some other reference, whether that's a stats textbook or that's a flow chart from a website, again, it's gonna lead there. And again, I think the statistics are far less intimidating when this is just saying what are the odds of getting data that are this where the means are this different based on random chance alone, and saying, well, about 5% of the time you would expect means to be about this different from one another based on random chance alone. And that's a pretty small chance. So, we're going to conclude that, this behavior did affect weight here in this. And then I think that just makes the stats less intimidating when you're saying, that math that we did, that was really the same process we were going through with our eyeballs. And we're not shutting off our brains and just plugging things into that equation and having it tell us the answer. We're looking at the data critically and then using the statistics to, help put some kind of confidence to that conclusion, if that makes sense. So those were the examples that I wanted to work through. Do we have any audience questions right now, Blake?
There are none currently in the chat, Aaron, but one question I have is maybe we could spend a little bit more time talking about what are the most appropriate descriptive stats to show? Because I know one thing we talk about in different teacher trainings is how there's kind of an art to graphing, right? Like there's some messiness and your ultimate goal is to answer a question or to communicate a story that answers a question. So would you mind if we just spent like 2 minutes looking at the different descriptive stats and which one you think is most appropriate in this case?
Yeah, and I think, again, I really like if you're trying to compare groups in terms of some numeric variable and your data are somewhat close to normal. And here we'll look at the descriptive, we'll look at the histogram. And these data are not perfectly normal. You can see that they're a little bit skewed and they have a longer tail on the right than they do on the left. That's a function of body weight is bounded by 0. We cannot have a fish that weighs less than 0, but you can have some exceptionally heavy individuals in your population. So, but overall, this looks like a kind of normal distribution with a little bit of a skewed tail on one side. So I'm with this, I'm comfortable using descriptive stats like mean to compare these two groups. Now, if you have a crazy skewed distribution, it might be that mean is not very appropriate to compare the groups. Like we might want to use median if you're comparing, I don't know, salaries of Major League Baseball players to NBA players or something like that. Maybe where you have a really long tail, maybe median is better than mean. But in this case, looking at these, I'm fairly comfortable using means. And going back to the dot plot, I really like using, for something like body weight, I would almost never use bars to represent the means, because you can't have a body weight of 0. And so like if I go back in here, so like we originally, we're using bars, like you can use a bar in this situation, but it's sort of weird because, it's not something that could ever be 0. So I really like the dot and error bars like that, because it sort of centers you looking in the range of what's practically relevant in this case. And if I was actually making this graph for presentation, one sort of thing that I like to do, the default in DataClassroom, you'll see there'll be like rings around the points. One thing I like to do is I like to tone those down if I'm going to take my descriptive stats and put them right on top of the data like that. And I like this kind of a visual where the dots almost become sort of like a density smear. Like you can tell where there's a lot of dots and where there's a few dots, but then you also have the added visual of the dot showing you exactly where the mean is and the 95% confidence interval. It's laid right on top of there. So it just makes the relationship between the actual data points and the summary statistic like mean, it just makes it, more apparent. Also, I want to add, like, when you don't do that and you just look at this graph, like how much less informative is that versus this, right? Like and all the studies about how learners learn to interpret data show that, like, this is a real common graph to see this as a bar, right? You'll see this probably in a textbook you're teaching out of right now. Like this graph is fine, but my gosh, does it hide a lot of the variation. And it really gives, it can give young learners the impression that, like, oh, I can just compare the averages and see, which one's higher, which one's lower. But when you're, versus when you're looking at a graph that is like this, I think this really helps, make it clear, why do we even calculate an average in the first place? Why do we need to use statistics? Well, because, real data has a lot of variation. It's real messy. Something like body weight has a lot of variation in it. And so representations of data that don't hide that variation, I think are a lot more informative. And there's actually, I'll get off my soapbox here in a second, but there's definitely a movement in scientific publication to get scientists to publish more representations that show all the data points, because there's some practices that can border on deception when you're just looking at bars and you're not seeing all of the data there. So great question, Blake.
We have no further questions in the chat. We can leave it open for 30 more seconds for anybody to speak their final piece.
Well, while we're sort of wrapping up here and waiting to see if anyone has any questions or comments, we'll just say, if you have any questions at all, you can feel free to reach out to Blake or I. Blake is blake@dataclassroom.com, and I am Aaron@dataclassroom.com. We'd be happy to talk through stuff with you. If you're at an institution or school that would be interested in a data classroom license, we're also happy to put together a proposal and quote for either you personally, or if you need to pass that along to someone at your institution, we're happy to do that at any time. Yeah, well, if we don't have any questions, we are close to the end of the hour. I'll say we will be sending out this recording. We will also be sending out the presentation slides, and then we'll also be sending out some charts for supporting students in choosing statistical tests. A couple of ones that I like that I've used over the years in making different materials. So we will, what we always do is we create a web page for the event, and we'll put that up. It'll have all the stuff, and we'll email you the link to that.
Cool, and I'll just reiterate, I just sent out a link in the chat for feedback. For everybody who is interested in a PD certificate for joining us tonight, please fill out that feedback form. That helps us improve further future webinars. And I just want to say thanks for taking time out of your weeks. Hope you have a good Friday and enjoy your weekend.
Thank you guys so much. This was really informative. Thank you.
You're welcome. And with that, I'll sign off and say goodbye.